So the first thing I wanted to start with is just a quick recap, if you weren't here last week, of the resources that are available to you to find some existing 3D models. So those would be, the first one would be Thingiverse. These are largely not engineering files, but they do have some. For example, in one project I did, I had to modify an iris enclosure, and so some engineering related stuff. It could be good for medical models as well. If you had like skull or stomach or stuff like that, you may be able to find some anatomical models there. A more reliable resource is NIH 3D Print Exchange. And then you can search for some related stuff here. Obviously, they've got a lot of COVID stuff right now, but if you searched stomach, they may have like, I guess they don't have a lot right there, but let's see, like brain. Got a lot of proteins and stuff. You just kind of have to look through. There's more anatomical models than it showed here. And if you're doing more engineering stuff, then GrabCAD is a great resource. And that one, maybe you want to find like, I don't know. They got more engineering stuff here, like gears and enclosures and small mechanical stuff. They have like Arduino cases as well. So if you look on here and you find something that you like and it has Solidworks listed here, that means that a Solidworks file will be available. Once you make an account, log in, you can download that, and then you can modify those files. Or you can see how they built it as well. So now I'm going to assume that you've seen the first video that I've done, and you were pretty confident on the basics of SolidWorks, and now I'm going to go into more design for research related stuff. So we're going to make a part. We're going to show you how to make that part for a few different workflows. If I was going to 3D print it, or if I wanted to laser cut something, or if I wanted to sketch over a picture. Maybe you saw something in a journal that you're like, yeah, I want it to be pretty much like that literature stuff, and let me model it as close as possible. So if I can sketch over some schematic that they've got, that could be pretty useful. Or if you just want a cool logo on something, that's a great way to copy it as well. So I'm going to start making a part. And I'm going to start by making a microneedle patch. And I made one at the end of the last video, but I'm going to show you a way to make one that's a bit more robust for research. Say if I want to modify some design parameters fairly quickly. Going to sketch on a plane. I'm going to choose a rectangle and define the size of the base of the microneedles, which is just going to be a 1 centimeter square. I'm going to make the base 2 millimeters thick. And you'll notice that it extruded toward me. So the front plane is here right now. I'm going to sketch on the front plane itself. And I'm going to make the base of my microneedle, which will be a circle. So I'm going to make like a little cone. And I'm going to make this sort of at the limit of the sizes that are capable with the Formlabs printers. So you have a rough idea. If you were making a model with very small features, what is the minimum size I could get away with for that SLA printing? So 1/4 of a millimeter is like the smallest kind of small feature I can make for microneedles. I'm going to make a feature that I didn't make in the first video, but it's very powerful. And that is a reference plane. And the reason I'm making this is because one of the things I might want to modify is the height of my microneedle. And there's not a really good way to make a cone and change its shape without having to like fine tune a draft angle. I'll just show you that really quickly. If I was going to extrude like this little cylinder, I can't really make it a cone unless I'm adding a draft angle like this, right? And then it kind of depends how many degrees I put as to how high it is, the height of it. And I don't want to mess around with that. So instead of that, I'm going to do a loft, which essentially means I take two sketches and I connect them with I connect them by their exteriors. Right? I take two profiles, I kind of draw lines between them. And so I will show you that. So the first thing I'm going to do is set a reference plane. So there's reference geometries here, and I can do a few different things, but I'm going to define a plane as an offset from this plane. So traditionally, you can really only sketch on flat faces, like flat areas of your sketches or your features, or the front, top, or right plane. Now I'm going to show you how to create a new flat face from some pre-existing geometry. So I clicked on this front, and you see this distance right here. That will be the height of my needle. So I'm going to make it a 2 millimeter tall needle. You'll see that preview here. If you have questions as I go, feel free to jump in. When I make this new reference plane, I need to sketch on it. Right? And I usually click normal to make the sketch normal to my view, to just see it easier. And now I want to create a point that is the center of this needle. So this is the point sketch entity. I'm just going to click on the origin here. Okay, this sketch is done. And now you'll see that I've got a circle and I've got a point. And if I use my loft feature between those two, I'll get a cone. When you do it, you can do it between any two shapes. You can make like a square and a circle, and it will join the edges of those two. So really just make sure that your two outlines are selected here for the profiles. This green dot is kind of showing you where it's connected. So if I had like two squares and I wanted a cube out of the loft, you just make sure that that green dot is between vertices that are above each other. If you drag that green dot to like another corner, it would actually like make the cube like twist. So that would become apparent to you. If those green dots don't line up, then you'll see some funky geometry. Okay, so I've made a needle. I'm going to show you why that's powerful now with the plane. I'm going to right click, edit the feature, and adjust that to a 1 millimeter height. And now my cone is updated to the right size, just defined by the offset of that plane. And now I'm going to do the same feature that I did before, which was a fill pattern. So up in my commands, I can choose fill pattern. With the fill boundary, I choose the area. With my feature that I want patterned, I want this loft. And I can choose between any of these patterns. Based on what my area was, maybe it would fit better. If I have a target array size, I can choose that, or a target spacing, I can choose that. Say they're a millimeter apart. Right. This is choosing a perimeter that I don't want the needles to touch. So if I don't need a millimeter space, I can choose 0.5 millimeter. And it's going to tell me how many needles in this right here. So 81 needles. Okay. I'm going to choose that. And I'm going to add some fillets onto the corner here just because it looks pretty. So the lesson I taught last time was when I click the corner to be aware of this pop-up. This first box is usually the one you're picking. And that's going to highlight all 4 corners. And if my radius is small enough, it's going to preview that for me. If I get it too big, it's going to disappear. So you can just keep typing in numbers until it shows up, and that's how you know how big you can go. Okay, here's my microneedle patch. I want to know how much volume is in that needles, are in those needles. So I'm going to be using the evaluate tab, and I want to get rid of all of the volume that is not in the needles currently. So I'm going to cut off the base just for now. I'm going to sketch on the back face. I'm going to choose the back face and hit convert entities, which is going to give me the edge of whatever face I selected and convert all of those lines. What's nice about the convert entities feature is that it is kind of like a reference to that face. So if I change the face later, it will update the size of this outline to always match whatever the back face geometry is. And now I'm going to cut the height of the patch. You can do it up to the surface as well. So if I change the front face here, even if I make that base thicker, it will also cut it to the right distance. If I chose what the default was, it's just going to do 2 millimeters. And if I changed the height of that initial feature to 3, it's going to leave 1, right? So I don't want to do that. I want to make sure that my model is robust, and so that a lot of my things are based on references instead of like absolute dimensions. Okay, now I have just the needles left over, and I'm going to evaluate the mass properties. The most common evaluations we do are in measure and mass properties. Measure is going to give us like thicknesses and all that kind of stuff. And a mass properties is going to give us a mass if our material is identified. But in this case, we just care about the volume. If I want it in different units, go over to options, use custom, and then define it by something else, right? So meters or whatever you want. Nanometers cubed. It's a lot of nanometers cubed. Okay. Good, so now I know the volume of this. If I did want that mass, let's go to material, identify it. I'm gonna make it in cast iron. Ooh, changes the color. And then I get some mass in grams. So they're very small, so right. Okay, I can just roll back this cut, and now I have my base again. I can remove the cast iron, so it's not weird colors. All right, let's see, what are we gonna do now? So we designed it for 3D printing. Now let me show you what we're gonna do in the workflow for 3D printing here. We're gonna save this model as, I'll save it on the desktop as a microneedle test 1, and I'm gonna save the STL file. That's what I'm gonna be 3D printing with. So that's great. Now there's a software called Preform. That's what we use with all the Formlabs printers. Some of you may have used it already. I'm just gonna show you how to import this part and how we would print a part like the microneedles and why. First, I'm gonna open that STL file. It's gonna put it here. I can scale this. Sometimes I scale these parts if they have to fit into some pre-existing geometry, like I'm making a jig for a part for a machine, or I'm gonna put like hex nuts into the part or something like that. And I don't know exactly how they're gonna fit in there because polymer shrinks when you cure it from the printers. Or maybe I want a press fit and not a slip fit. So I will typically make a few copies of this and then see which one fits the best. I did that for Miguel's project where he had to fit in a PCB into the printed object or a case. So first thing I'm gonna do here is rotate it to a printable angle. And so you might think the SLA printer is the finest in the Z axis. I can get the finest resolution because the layer thicknesses are very small. So I want to print like this. However, that's not the case. There's issues when it comes to the viscosity, the surface tension of the resin. And if you print it like this, they're gonna look like tiny Christmas trees, which we've actually seen. So they're like blobs, like a snowman kind of shape. and they're not very sharp at all. So you actually want to print it like this at an angle as steep as you can without supports generating themselves under the needle tips. So I'll demonstrate that. If I do it a little bit too steep and I generate supports here, I'll put the supports a little bit lower. I'm going to change this to our gray material, which is the finest resolution. Get down to 25 microns. Okay, when I generate supports on this, that one looks okay actually, so I could print that. If I go any steeper, this may actually not generate because the tips are so fine that it could not resolve in the software algorithm. So I would recommend trying to go at like a 45, and you'll get sharp microneedles if you're doing that. And if you're sending this to the Mechie team to do printing, then there's some more options I'll show you. I can duplicate this. I'm gonna make 5 of them total, so throw a 4 in here. I'm gonna scale them like I told you. So highlight one, scale, and do like 1.03. That'll be 3% bigger. Maybe one is a little bit smaller, 0.95, something like that. Generate supports, and then at the end of it, you're gonna save this as a .form file, and then you can send it to us and we can very easily print exactly what you've laid out. All right, so that's how to make it 3D printable. Let's do a small design that would be great for laser cutting. Does anybody have an example of some kind of thing that they laser cut or would like to laser cut? Feel free to jump in. No. Okay. I'll give you, is anybody typing anything now? Okay. I'm gonna laser cut a snowflake for Christmas, right? And those, like, fold the paper, you cut it with the scissors. Okay, we're gonna do a little demo where we generate that pattern and then we laser cut it. So let's do that. So we're gonna pretend like this is our paper. And in this design, we're gonna use some angles, which is gonna help us out. So, and mirroring and symmetry, which we haven't used before. So this is our paper all folded up, right? And we need, I don't know how big, okay, let's do this. Our snowflake is gonna be a 3-inch radius. And this we want to be 1/8 of the final geometry. So we're going to do 360 divided by 8, and that'll be 1/8. Okay. And I'm going to join this together. And now what we're going to do is we're going to imagine these are scissors, and we're going to cut out little shapes. Okay, something very basic. What I'm going to do is use the mirror function. I'm going to highlight this geometry, hold Control, click these 2 dimension tools. I don't care about those. And I'm going to mirror entities. And this is going to be our mirror line, so I don't want to select that either. Click Mirror Entities. I'm going to have the one selected. I'm going to mirror about this line. And I have Copy selected, so it doesn't move my existing geometry, it just copies it. Click that and right click. Okay, and that's 1/8. And now I need to make rotational symmetry, right? I need to generate that 4 times around. Okay, so we need an axis to rotate that thing. So let me create an axis. You could also get away with a circle that's around this origin. So we're going to do another reference geometry, but it's going to be an axis this time, and it's going to be 2 planes. So I'm going to have this like axis that's normal to that geometry coming straight out. And that's going to be, if I can view it this way, this plane and this plane. Now we see the axis. I'm going to rotate that about and go. Because I want to rotate in the sketch, I need any geometry I'm referencing to be existent before that sketch. So I'm just going to drag this before. Okay. Now when I go back into the sketch, my axis is there. And I'm going to do, instead of a linear sketch pattern, a circular sketch pattern. And this is my axis that I will revolve. And I choose this one. Yikes. Okay. Maybe I have to choose here. That's not working. Let's throw a circle in there. If I ever use a geometry for some other function except for making a feature, I make it construction, which means that it's not actually existent. I'm just using it for some kind of reference. So that makes it a dotted line. Select this geometry and create a circular sketch pattern. And by default, it's 4, but I can change that if I wanted to. If it wasn't 1/8, I could do more. I can also pattern it not around the full circle, but I could do like just half of it if I wanted to. And in that case, it would just be 2 of them instead of 4, but not equal spacing. So anyway, here's our snowflake. In order to laser cut something, we need some solid geometry. We can't do it just on sketch lines. So let's extrude all these areas. So you'll see the selected contours. This is the same thing when I do a feature based on a sketch. I can select just the area that I want to extrude. I don't necessarily have to extrude all of it. I can just pick which ones, right? So in this case, I want all of them. For laser cutting, it doesn't matter how thick it is. I just need some pattern. Oh, this is the worst snowflake ever, but it's fine. Okay, to do laser cutting, I need a DXF or a DWG file. And so it's the same as saving an STL, but instead I drop down and I choose this DXF. I'm gonna make snowflake. Desktop. When I save this file, I get these options over here. Choose faces and choose the face that you would like that pattern to be cut into something. Checkbox. When you do that, it's going to show you the preview of the laser cutting vector files, and then just save that. You'll be all set. From there, I would open it in Adobe Illustrator. I would make the stroke width very, very small, like 0.002 millimeter, and then I can hit File, Print, and make it go to the laser cutter from there. So that's how you generate some laser cutting files. If you have geometry that's the same thickness all over, this is the fastest way to prototype something that's flat sheet based. Laser cutters are also extremely powerful in terms of the versatility of the feature size that they can cut. We've cut holes down to 250 microns. I bet we can go smaller. That's just what I tried recently, but extremely tiny holes. And that's probably based on the thickness of material that you're cutting and how rapidly it melts. But that was in paper. Okay, so that was laser cutting. Now we're going to design something for molding, right? I've done quite a bit of work for Nicoletta and Ying, maybe some other people, based on 3D printing some geometry and then doing silicone molding of that and then casting PCL into it. We can also design something for like injection molding. So in most of those operations, I may want to make some geometry that's going to be my final part that I injection molded, but I need to make the mold for it, right? Which is the negative geometry, the inverse. So I'll show you something very basic on how to make the mold from that part. So let's pretend we're going to injection mold those microneedles that I just made. So where do we have that? Okay, here's the microneedles. Okay, what I'm going to do is I'm going to basically generate a sketch that's going to be my mold block, and then I'm going to subtract out microneedles from that. Okay, Maybe I want to two-part mold as well, so I'll do that. So we'll sketch on this face. You have to see how the part can be removed from the mold. One thing you may want to consider doing is having draft angles on the side of this original piece. So let me go edit that feature, add some draft to it. You gotta make sure it's in the right direction. So not this way. I'm gonna flip it around. I'll exaggerate it so you can see. Okay, so the base is a little wider, so I'm gonna pull it out of the mold that way. Now I'm gonna sketch the mold itself. So this is gonna be, if you're actually gonna use our Galam injection molder, there are some pre-existing geometries that fit in some nice aluminum blocks. And those files are available on the Dropbox. So we can get those to you. And you can do the same subtraction operation using those two mold halves. Okay. So let's say this is our mold block. The basic thing that you need to know for this is we're going to uncheck merge result, which is going to give us a separate solid body. Okay. And that is here. So make sure that you've got plenty of volume on outside of the part. Uncheck merge result. And it looks like it just got absorbed into that giant block, but what you're going to notice is this line existing here, which tells us that they're actually separate. You'll also notice under the solid bodies, I've got two parts. So I'm going to choose both of those with shift. I'm going to right click, do combine, and I'm going to subtract them. And the main body I want to be the mold, and the body to combine will be the other part. It could be multiple parts as well. So you could subtract 10 things from the mold if you wanted to. When I click combine, it's going to show me the cavity left over by those needles. If you were actually doing this for injection molding, this mold would be 3D printed, in which case the negative cavities are not as easy to print as some positive shapes. So resin would definitely get stuck in these holes and would not resolve if you were doing that. So just be aware of what technique you're using in the process and what it's capable of. All right, now I'm gonna make the mold like half on the other side. So maybe I need like some path that goes in and feeds the plastic into that mold. So I'll sketch on this mold half and make the injection sort of geometry. And for that, I'm gonna use a revolve feature. So let's see here. So the part that I'm going to put plastic in is usually like a cylinder with a cone on the top. So if I sort of create that in a two-dimensional sketch, right, that's my sort of a cross-section of what they call a sprue, which is the part that feeds the plastic in. I'm going to do a revolve about this line. And I'm going to uncheck merge result. So now that's another separate solid body. I'm going to make the other mold half, which is just, a big solid block. There's nothing fancy about that. 7.5 again, uncheck merge result. And now I need to subtract this piece from the other two. So that's this one. So I'm going to combine all three. May need to duplicate, I'm not really sure. Fine. Subtract it from this one. Soki, do you have an idea of what to do here?
You could have just created one body with a mold
Oh
and
yeah, and just
subtracted the resolve, then revolve, then split it.
okay,
It's an
that's a good
option.
idea. Yeah. All right. So with this mold, I'm gonna also extrude out the backside, 7.5. Now my revolve should be on a different plane. So I can actually move this over to where it should be, which is here. Nope. So I'll show you one more thing. So if I need to make a plane that's in between two faces, I can do that as well. For my reference, I'll just pick either side, and it will create a midplane in the middle. And I drag this back so that I can use that plane with this sketch. Great.
Might be good to also show select other to select like the internal face if you
Option.
want to do it that way too.
Yeah, let's see. I usually do that when I'm doing assemblies. So, but in any case, let's keep going here. We want to subtract the sprue from the whole piece. Now I can look inside with the cross-section view, so I can see how it's been cut out. That's probably not the ideal way to cut it because that's going to mess up some of my base that I would have to cut off. But in any case, you can see how to subtract parts from each other that way. Okay. Let's see. All right, last thing I want to do is I want to trace a sketch picture. So let's just pretend this is our part now. And I don't know, you might want to put like an MIT logo on something. So, you know, copyrights be damned. We're just gonna, you know, copy any picture that we want. Throw it on here. And you can do a JPEG or any kind of file type and start a sketch. Once you start the sketch, you're able to import the picture. And watch carefully, you're gonna go under Tools, Sketch Tools, Sketch Picture. And you've seen some of the other things that I've done here. Let's see what we've done. Usually the pictures that you get, they're gonna be really large and way bigger than your part. So you can note how long it takes to load. The first thing you're gonna do is go over here and scale it down to roughly the size of your piece. And then you can go and drag it over the top. Okay, roughly position it. If you knew the size of your block or the size of the picture, you can type in exact dimensions here. So it'd be like -20, -10, roughly. Okay, once the picture is there, you can double click to get back into those settings. You can change the transparency of that image so you can see some geometry that's behind it if you needed to. And now you can just start tracing. So I'm just going to use a rectangle because it's quick. Right. You can see some of those tie lines being created to help me position things more precisely. All right, things may not be exact, which in that case, you just go back and drag some lines after the case. Okay, now I can just extrude or cut that. And you can do a very small amount and it's still going to be visible. All right, let's say I want to put that in a journal, right? And now I want to like make it look nice. So I go over to this appearances, the colorful ball over here, And now I can add colors to this object, right? And I'm just gonna kind of go through and, pick a plastic or whatever. I'm gonna choose, a dark background here. And when I let go, I can choose, to what level I want to apply that color. Could be the whole part, could be the body, could be just that feature, could be just a face. Right? So I'll do it to the whole body because now that logo was like red and then gray down here. So I can go back and, add layers to it. I can, just do that on the last feature and do that again with like the gray color and just add it to that face. Right? If I want to add it to the sides, go over to the one on the left, right click, edit, and now I can just click more faces to add those to the list. And what Soki was talking about was selecting other, which is just if you can't see a face in your field of view, right click, select other, and you'll get this short list here, which will, once you highlight over these faces, it'll show you where they are. They may be behind other things, harder to see. Okay. And now I've got my part and it's colored and, let's see. Maybe I, want a rendering or some nice view of it. If I want to hide some things, there's this eyeball here, and I can hide some of the sketches I made or the reference planes I've created or the axes that I created. That would be here. And now I can view it. In order to get a nice rendering, there are a couple things. There's render tools, which is here. If I don't see that, I can right click and make it show up. Under here, you want to select your field of view. You want to choose a render region. You can do options here, which will take a lot longer or a lot shorter based on the quality that you choose. So if you just have it good, then it will take the shortest amount of time. And if I check and I choose final render, I can turn on perspective view, which means that things that are farther away get smaller. So it's more realistic, but you don't have to. It's just your choice there. So then when you do that, you should start to generate it. And you need a fast computer to do this kind of thing. So you may outsource it. So as you can see, there's a status there. And you can kind of see what it looks like. When it makes that little noise, that means it's done. You can see some maybe previous ones that we've done here. Oops. Right. So you can tell based on the noise in here that it's lower quality. You can choose the pixel size of these. So if you needed to put it on a poster or something, you can blow that up. So that's basic rendering. What's very common is to remove the background in all this because by default, it's like some gray shady stuff. So in the appearance, let me just get rid of this real quick. In the appearances, I'm gonna go under the scene and right click on this, edit the scene, and turn the background image to none. That's gonna give me a plain white background. If you see any shadows on the ground, you can get rid of the shadows. Right in here. Floor reflection and floor shadow, you can get rid of those. So then that's good for basic schematics. Now let's say I had a part that's got, or let's open an assembly so you can see maybe multiple pieces put together. Let's see if I've got one. Somehow. Let's see if I've got any assembly files. Okay, there's one. Oh, great. Okay. If I'm making an assembly, this might go a little bit slow. I can insert individual parts with this insert components. If I have files that are open, they will be available here. So I recommend if you're making an assembly, open all your parts and they'll just be easily there in the list. If you've got multiple of the same part to put in, just click this little pin. And after I click here and click in the assembly, you'll be able to just click a bunch of times and put a bunch of the same part in. If I want to start aligning things and moving them around, I'm going to use this mate function quite a bit. In which case, let me just get rid of like a lot of these and show you something simple. Okay, so a lot of the times we're putting stuff inside like 000 capsules or whatever. Maybe you want to see if our design is going to actually fit in one of those. In the Dropbox, I've got a file called like pill models, in which case I made a configuration file for every size of pill. And to access that, you just would click this configuration manager and they'd have a list of all the sizes, and you can just double click and you'll have that size pill. Okay. Let's get rid of any pre-existing mates. Okay. So here's my pill. I have two halves. They're not defined by position in any way. The first part that you drag in is going to be by default fixed in space. So that must have been this piece. So I can't drag it. If I wanted to drag it, just right click and choose float. That'll enable you to move it. If I have two cylindrical objects, they're going to be defined initially by a concentric mate, which mates two circle geometries to be concentric with each other. So I'll show you what that means. If I click mate and I click on this cylinder and this cylinder, by default, it's going to choose this one, concentric, which means they're aligned this way, right? Okay. Then I may want to like put them together, right, to be the actual like pill size. In which case, I'm going to have two flat faces that are touching somewhere in that model, and that mate is going to be coincident. So I want to figure out what two faces are going to be touching in the model and click those. So that's going to be this one. And inside the pill, it's going to rest on this little face here. Sorry, it may be, you just take a careful look at it. Okay. It may not actually be there. So we'll align it with like this ridge here. So I chose a face and an edge, and that just means that it aligned them like this. I can also choose a distance. If I didn't want this coincident, I can get rid of it. And then I can say I want them to be a certain distance apart. So click, and choose a distance here. Sorry. Okay, well, if I selected them correctly, then there would be a distance. You could click here and then you could set that distance. Okay, so that's basic assembly. Let's see what else we got. Okay, so we traced the picture. We did laser cutting, designed for some molding operations, which means subtracting them from other geometries. Designed for 3D printing, where we talked about, sort of the minimum resolution of the printers and how to orient parts in preform. is there anything else that you guys would like me to go over? Any particular challenges that you're facing when designing models?
Hi, Adam.
Hey, Mike.
I think I just want to recap two questions. So first one is basically that I remember that in one step you basically created an X and then you moved one step above. Looks like cycle key mean gives me an answer, but it's not very clear for me. Can you explain more of it?
Absolutely. So whatever function I'm performing,
Yeah.
they have references that it's using to perform that function, such as I'm extruding like this. What was this reference that I made? Let's see. Let's go to the. Let's go to the microneedles. That one. Let's just make one. Okay, so I'm gonna make the cylinder. And now I'm going to, let's say, I'm gonna sketch here and I'm gonna do convert entities, which is referencing the top of the previous cylinder, right? Let me see. So, well, let me do the same thing I did before. Okay, so I needed to revolve something axis, and the axis did not exist yet before that function, right? So I had made something that I needed to revolve around an axis, and then I actually made that axis after. So let's say I needed to revolve like this rectangle, but it's not at the origin. Maybe it's like over here. And I want to revolve it like around this line, but it doesn't exist. And if I went and then I made that line, from two planes, so let's see. Right plane. Let's do a different one. Okay, so I have this axis, right? And I want to revolve it and make this giant donut, right? I can do that now because my revolve, I have these things that are pre-existing, but if I went back here and I wanted to revolve, there's no axis here, right? So I need those, whatever I'm using in that function, to exist before that function happens and not after. It's called like a parent-child relationship between the features.
I see.
So this kind of leads into the order of operations that you do being important in SolidWorks, leading to the best practices for modeling being that you should create all your positive features first, then make all your extrude cuts, and then make all your fillets or chamfers at the end. Because you may change something about your model, which will break because the features that you've created after were referencing something that no longer exists.
I see.
Yeah.
And also, I think that at one point that you uncheck a box that is called merge results or merge units.
Yeah.
Yeah. So basically, can you explain what is that box doing?
Sure. So I'll make a simple geometry, and maybe I wanted to subtract two blocks from each other. So let me make another geometry here. And I'm going to like extrude that like into this block, or even like through it, say like halfway. If I just make that feature as it is now, those two parts will overlap each other and they will be fused together. That merge result essentially like fused
Oh, I see.
solids. Yeah. So now I still only have one solid body, which is this whole block. It didn't create any new geometry there. However, if I go back and uncheck that merge result, that piece is going to be disconnected and it will act as two separate pieces so that I can perform functions on them independent of each other. One way this can be very useful is if I'm making a cut in a different plane, like here, and I want to cut it, but I don't want to cut it through both objects. I only want to cut it through one, right? And then if you look down at the bottom here, I can choose which body to cut through, such I can just cut through this one.
Got you.
Yep. And so then you can kind of see what it did here. I guess it does not look like it cut very well. But you can also preferentially like hide bodies too. So, and you can see it actually did cut. Yeah.
Thank you so much.
You're welcome. Okay. Let's do one more thing before we close out. I'll just show you something kind of fun. If you're new to SolidWorks, maybe it will be something interesting to do. That's going to be a swept boss base. So the first thing I'm going to do is make a helix. This could be if you want to make any screws by scratch or something like that. The first thing I need to do to make a helix is make a circle. And I'm going to make it a 1-inch circle. I'm going to exit the sketch and use that circle within the Features tab to use curves, helix, and spiral. And I'm going to make, you can define a spiral by these combinations of parameters, in which case I want to do height and revolution. I want to make it a 3-inch tall helix, and maybe like 1 revolution is fine. If you were defining screw threads, you would use the pitch in that case instead of revolution. You do pitch, maybe height and pitch, and then typically the threads are a certain amount per inch. So you do like 1 inch divided by 24 or 1 inch divided by 36, whatever the thread TPH value would be to get the right pitch. Okay, now I have helix. And I'm going to sketch on the same plane some kind of polygon. How many sides? Let's go with 5. So I'm making a pentagon in that case. This one has degrees of freedom, as I said in the first video. So I'm going to set that with 1 horizontal line and 1 dimension, maybe 35. Okay. And now I have a profile and a path. And with those two things, I can do a swept boss base. Exit. Okay, and first I choose the profile, which is this one. And then I choose the path, which is this one. Now I can create very fancy looking geometry. And if you wanted to, 3D print something like a fancy cup, then you go and use your shell function and make sure the top is hollow and make the thickness like 2.5 millimeters and show my preview.